Well, here we are, video 2 for section 3.5, and we're continuing with transformations. So far, all we have looked at are the shifts. But we're going to begin, actually, example number 7 really provides a way, do you understand what's really going on? And what it asks is this. Suppose that we know a function is increasing on the interval from 2 to 3. Then we are asking, what interval is the graph of f of x plus 5 increasing? Well, if you learned from the last section we look at this plus 5, it's going to be doing a shift of some sort. The question becomes, is it up, down, or left and right? Since it's directly connected to x, that means it's either going to be left or right. More importantly, it does not behave. So we're going to be shifting it 5 to the left. So if it's increasing from 2 to 3, and we shift this whole thing 5 to the left, then that means it will be increasing, the new function will be increasing from -3 to -2 when we shift the whole thing 5 to the left. And so this really isn't difficult as far as mathematically speaking. It's just to work your way through and understand everything that's going on. Then we have the next, well, the final section in this group, 8 through 13, the remaining. We're still going to be graphing. And so the same process. It's going to be, we're going to have to figure out what is the parent function, put those points in, then we're either going to shift, either compress or stretch, and reflect. And we're going to look at different times, when do you compress, when do you stretch, and all this good stuff. But the same rules apply. So example number 8, f of x equals 3x cubed. Well, first thing, we have to find the mother function. Well, the mother function is the cube. And so we go back to last section, the cubic function, 0, 0, 1, 1, 2, 8, -1, -1, and -2, -8. So we've got those points. Now the only thing that's added to it is this 3 right here. Now we ask, is that 3 directly connected to the x or not? Same question. And many people would say, yes, it's directly connected. But it truly isn't, because the x cubed, the cubed is affecting the x, but not the 3. So in this case, the 3 does not directly affect the x. If it did, it would be a left-right sort of problem, and it wouldn't behave. Well, in this case, it's not directly connected, so it's an up-down, and what's it going to do? It's actually going to stretch. It's what we call stretch. It's going to be stretching the y values, because that's what it affects, stretch by 3. Now, what that means is this. If we have 0, 0, the y value is 0. Stretch that by 3, or in other words, 3 times 0 is still 0. This one right here, the 1, that's the y value for 1. If we stretch that by 3, that's going to go up to 1, 3. Likewise, if we have -1 here, the y value is -1. Stretch that by 3, and it goes to -3. This 8, this y value of 8, stretch it by 3 is 24. Well, that's well off the graph, so I'm not even going to try that. Likewise, -8 would stretch all the way down here to -24. We don't have those. So now I'm going to use this point, and this point, and basically what it's doing is I have, in essence, just sort of taken the cube function and just stretched it 3 times its normal size. And that's why we call it a stretch. Just realize that if there would have been parentheses right here around the x, then it would have been left, right, and we wouldn't have taken the x values and stretched by 3 because they don't behave. Instead, what we would do is we'd take them in and be 1/3 of what they normally would, because they won't behave. The same rules apply on these stretches. It's just you need to realize it's harder to determine, does it directly affect x or not. Example number 9. Number 9, f of x equals 3 times the square root of x. Okay, it should be rather obvious. We're talking absolute value. The absolute value function is what we're talking about in this particular case. So I can just put my points 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and I know it's going to have a V shape. Those are the things I know right now. The only thing added to, or additionally to, the absolute value of x is the 3. We ask ourselves, is this 3 directly connected to x? No, it's not inside the parentheses, so that means it's an up-down thing. Well, what's it going to do? Since it's multiplying, it is a stretch by 3. So we look at the y value here, and it's the stretch the y value, not do anything with the x value. So we're not going to shift left or right, we're going to stretch this by 3. Well, 0 stretched by 3 is still 0. 1 stretched by 3 is 3. 1 stretched by 3 is 3. 2 stretched by 3 would be 6. And take this 2 and stretch it by 3, and we get 6 there. So what happens is normally our fatter V has been stretched upward, or it sure has gotten a lot skinnier. And that's what happens whenever you stretch things. When you stretch things by a number greater than 1, then it will generally get a whole lot skinnier. Example 10. F of x equals, we got a whole bunch of things going on here, 3 times x plus 1, the quantity squared, plus 2. Okay, first thing, the mother function, the parent function. Well, I've got x being squared, so it is the square function. So that means I should be able to, get some straighter lines here. And the square function goes 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And remember, it's a parabola, and it's still going to look like a parabola. It does not change the overall shape. But we have several things that we need to do. First off, what happens here, this plus 1? Plus 1, directly connected to x, is either left or right. Since it's directly connected to x, it does not behave, so that means it's going to go 1 to the left. Normally 1 to the right would seem logical. Then we have this plus 2 here. This plus 2 is not directly connected to x, so that's going to, since it's being added, it's going to be an up-down, and it does behave since it isn't directly connected, so it's going to be 2 up. This 3 right here tells us we need to do the a stretch. And we ask, does the 3, is it directly connected to x? The answer is no. So that means it's going to affect the y values. It's going to stretch by 3. Now the question becomes, how do we do these and in what order? Basically, what you want to do is you want to do your stretches first and then your shifts. Okay, so we'll stretch by 3. So this one will stretch this by 3. It still stays right there. Then we go 1 left and 2 up. So we end up right there. And this would be the point negative 1, 2. And this becomes our vertex. Okay, now this one. If we stretch by 3, we go up to 3. Then we go 1 left and up 2. So this would become the value 0, 5. And then we would get a very skinny, when we did all the transformations, when we did all the 1 lefts and 2 ups and the stretching by 3, we would get a skinny parabola based right here. Now another way to look at it is once you find the vertex right here and it shifted 1 left and 2 up and there's not going to be a stretch, then from this point forward everything is going to be stretched by 3 with respect to this. So we can sort of think of it as being, you know, here's our new set of axes, and then we would just take what would normally be a 1, 1 and stretch it up to 1, 3. And this one would be -1, 1, but it's going to be stretched up to -1, 3. And then likewise there. I find this a whole lot easier to do it this way, is just find the vertex and then do the necessary things from that point. In other words, create just a new set of axes and go from there. It's really a whole lot easier to do it that way than it is to try and deal with all of the which one do I do first and stuff like that.